Hi, everyone. Thanks for joining this webinar on how to efficiently design biodiesel production. I'm joined by my colleague Alejandra Peralta. She worked for CHEMCAD support for a long time at chem stations, but she last year, I believe, Alejandra, moved into a solution consulting role. So she's helping our technical sales.
Thank you, Nam. Good morning, everyone. Welcome to a new ChemCAD webinar. I'm Alejandra Prata, as Noel mentioned, and I'm a solutions engineer consultant and a lead application engineer at Chem Stations. I have been working in the process simulation area for more than 20 years, and I'm excited to be your speaker today. Our topic today is how to efficiently design biodiesel production using a process simulation software. So we're going to start now. Sorry. All right. For those not familiarized with our software, ChemCAD is a process simulation software made by ChemStations. Our company has been around for more than 30 years. And ChemCAD helps engineers and professionals in different industries to create accurate models in complex or simple processes to improve efficiency and to make data-driven decisions. We are present in more than 113 countries. We have partners and distributors around the world, and we have a strong presence in universities in the US and around the world. Today's agenda will be an introduction to our topic, which is biodiesel and how to efficiently model these type of processes. We're going to talk about the objective, where we're going to outline the goals for this session, an overview, an introduction to the biodiesel process, production process. So we will see fundamentals of biodiesel production. We're going to discuss feedstocks, challenges in the biodiesel production. We're also going to take a look at a case study and a demo using ChemCAD. We will discuss the benefits of using ChemCAD for biodiesel production. Some of the resources available in ChemCAD and some in the key takeaways from this presentation. To start off, let me set the stage for why this topic matters. Imagine being able to optimize every step of a biodiesel production process before setting up any equipment. So in your project, where every choice from feedstocks to reaction condition is backed by data. Today, I'm going to show you how simulation software can help us to design biodiesel processes more efficiently, saving time, cutting costs, and improving performance. But first, let's talk about why designing a biodiesel process can be so tricky and how process simulation software can help us to get it right. So the objective of this session is to demonstrate how to efficiently design a biodiesel production process using ChemCAD and concentrating on flexible feedstocks design and optimize reactor conversion. We're going to explain how to optimize energy usage throughout the biodiesel production process with ChemCAD to ensure cost-effective and sustainable production. So what is biodiesel? Biodiesel is a renewable alternative to fossil fuels made from organic oils and fats. Transesterification process convert those oils, fats into biodiesel. Why is this important or economically important? Because it offers sustainability and energy security benefits because it also reduces our reliance on fossil fuels, and can use different feedstocks. For example, vegetable oils, animal oils, algae, etc. How CHEMCAD can help us design, optimizing, and simulating biodiesel production? Well, CHEMCAD allow us to create detailed process flow diagrams of biodiesel production process. You can simulate energy balance and mass balance and optimize energy integration. You can model key operations for the process, such as reactors, separators, heat exchangers, etc. CHEMCAD also help you to evaluate different feedstocks and project and product yield in cases you have different sources from your feedstocks, and assess operating costs and improve sustainability. Why are feedstocks, why is challenging? Why feedstock challenges in biodiesel production? Well, feedstocks can vary in composition, so the fatty content might be different, some moisture levels, and also the impurities that come in the feed at the point that some oils and fats might require a pre-treatment process before getting into the translocation process. Other challenges is process efficiency. Depending on your feedstock and your process, you may have different yield variation, so that you will get a different percentage of recovery of the fatty acid or FAM at the end of your process. Also, it has economic impact because, as I mentioned before, you may have different sources of feedstocks, and that will cause some issues in the data, so that could change the cost of the project, and also an impact on the process efficiency overall. Sorry about that. Okay, so we're gonna talk about a case study. And the case study we're gonna present today, it's we're gonna build a alkali catalyzed process, and we're gonna try to obtain 99% recovery of the fatty acid methyl esters that we're gonna call FAM. When you have a process like this, and probably you have a PFD that you need to create or you would like to model in a process simulation software. So how do you begin the process? You usually begin your process by thinking about what thermodynamic model I need to use. What components do I have? Do I have enough data for these components? So the first thing is, okay, thermodynamic. What thermodynamic model? Usually for a biodiesel process, you would like to use an NRT, an activity coefficient model. NRTL activity coefficient model is usually recommended for non-ideal behaviors, which refers very well to the components in the biodiesel process. Also, in the biodiesel process, you will, at some point, you will get a liquid-liquid approach, so that in those cases, probably modified unit fat will be a good option to predict those two liquid phases and the activity coefficient interactions between the methanol and the oil, and the glycerol and the oil. For the components, depending on the amount of data you have, you will need to perhaps create a new component. And that takes us to how do I create and integrate custom components that are not available in CHEMCAD. And I'm going to show you that in a moment. What type of data is essential to build a reliable simulation? It depends on the unit operations that you will be choosing in your process. For example, if you are separating or you have distillation columns, you need to have good vapor pressure and heat of vaporization data. If you are willing to do some heat integration and you're going to be using heat exchangers, then heat capacity is vital. It's a vital asset for the data that you need for your component. Or a heat of formation and give of formation if you are looking at reactors. So let's get a look at the software right now, and so we can start creating our process. Okay, so this is how the process would look like. And the benefits of using CHEMCAD for the biodiesel production comes to where you need to explore and enhance some of the process design, the efficiency and optimization, and you're trying to improve sustainability of your process, right? So let's open CHEMCAD right now. Let me get that here. Okay. So this is our process simulation CHEMCAD. We're going to start, as I said, one of the things that you think about when you start your model is, do I have enough data? Do I have all the components required for my process? CHEMCAD has more than 2,500 different components in the database. For the biodiesel, we have some components that we use for an example, but also we have other data not in the database that we can share with our customers. In this case, if you don't have data, we don't have data for your particular feedstock, or if you have an oil, you need to create a new component. And the way that you create that new component in CHEMCAD is by going to component database, and you need to click on new. This will bring you to this dialog right here. We have different correlations for the creation of components, and you can find more information about those correlations in the help. I'm not going to go through all the correlations because of time, but usually if you want to create a quick component, and in this case it won't be something that you're going to burn, or it is an electrolyte, we're going to use a zero component correlation, and you can give it a name. And when you see this text in green, those are the specifications that you need to specify. So we're going to specify 114 Celsius. And as soon as we do that, we click on OK. CHEMCAD will take you to some dialogues to see which correlations you want to use. We're going to use defaults, so I can show you how this component is created. And as soon as it's created, it will put it into a user component folder that is called user components PPDB. For more information about like different databases in CHEMCAD, please get to the help or contact our support team. You can create several of them. You can share with your peers But you can also have your own user component folder inside of CHEMCAD. I'm going to click on OK, and as soon as I click on OK, CHEMCAD with those correlations will try to will calculate some of the critical properties for my component. If I look at the synonym, it will use the standard name that I just specified. And if we look at the basic data, it will calculate some of the data. This data doesn't mean it is accurate. If you want an accurate component and accurate results from your simulation, you may need to change some of this data. Especially it will calculate a molecular weight, but if you have the component elements and the equation, you can specify it, and CHEMCAD will calculate the molecular weight for you, or you can enter it. For the heat of formation and gift of formation, I said that if you're planning to use reactors, you need these two numbers in here. You can add them, and remember, as if you have enough data for your component, you will have better results at the end of your model, okay? CHEMCAD won't have correlations to calculate any of these components, but if you have experimental data, you can use this property regression tool so that you can regress some data for your component. In this case, I created component oil 2. If I have experimental data for vapor pressure, for example, I can add a new library vapor pressure data. So I put a name, click on OK. And CHEMCAD will it will calculate coefficients for you. And you need to start getting your experimental data in here. Okay, so this is the way that you create components in CHEMCAD. We will go ahead and because of time, I have set up my simulation with all the unit operations I need for my biodiesel production. And we will be getting some part of the process and specify so you can see how CHEMCAD calculates those in the reactors and how we calculate vapor liquid equilibrium. So reactions in biodiesel. We're going to concentrate in our process. We're going to concentrate on the transesterification side of the biodiesel process and the catalyst removal of the process. So let's go ahead and go back to CHEMCAD. And right now in my process, I have 3 feeds. I have the alcohol, which is methanol, the catalyst, which is sodium hydroxide at 25 degrees and 100 kilopascals. And we have the oil already. I created this oil, cloning a component called triolene or triglyceride in CHEMCAD. And I added some, or I re-regressed some of the vapor pressure data that I found in a paper. So this component is already set up. If we go ahead and look at my component, so my oil has heat of formation data, gift of formation data, all the critical pressure, molecular weight, formula so that it can react in our reactors and already has vapor pressure data and heat capacity. Well, all set with my oil. I have a bunch of like different other equipments that we are not gonna look at, but I have pumps and heat exchangers and also some mixers in here because these methanol removal, we're gonna remove the methanol and put it back into the system, okay? So in the transitification, the chemical process where the oil reacts with the alcohol in presence of a catalyst to produce the fatty acid or the FAME. So we're gonna go ahead and double click on the reactor, and we're gonna tell the reactor we have just one reaction happening. It is in the liquid phase. We're gonna run it isothermally at 60 degrees. And then when I click on OK, CHEMCAD takes me to the equilibrium data. We're using an equilibrium reactor. And we need to specify the kinetics. What is happening in the reactor? So in the reactor, we're going to specify that oil is the limited reactant or the base component. And we're going to specify our reaction, oil plus methanol produce FAME, which is the fatty acid methyl esters, and glycerol. And we're going to specify the coefficients. And we need to specify the fraction conversion. It's going to be 95%. Before running my reactor, I don't have any compositions at the entrance. So we're going to go ahead and run these unit operations first. And I run selected. So I have a feed stream for my reactor that has methanol, oil, and the catalyst. And now we're going to run the reactor. And we will check that FAME was created with glycerol and the oil and the methanol that I added reacted. Now we're gonna run several other unit ops for the methanol removal. And let's make sure I have a little bit of FAME in here and most of my methanol. And then in here, I should have the rest of my FAME that will go through liquid extractor. So that I'm gonna run this part. Remember I mentioned that I was using the one part of my flow sheet was using NRTL as my thermodynamic model, but other part of the flow rate that the interaction of the methanol with the oil and the glycerol with the oil require two liquid phases. So I was using a different thermodynamic model. In CHEMCAD, you can use different thermodynamic models in one flow sheet. I'm going to show you how this looks like. So if you want to use a different thermodynamic option for certain unit operations, you need to select the unit op and go to thermodynamic settings and click here where it says set local thermodynamics. Then click on OK. If you see, it says that the local K value is modified unipack. But if we see in here, the global thermodynamic is NRT and latent heat. And it's also locally selecting that I have three-phase option. So I have liquid-liquid in here, vapor, liquid, liquid-solid, turn on. So in this case, CHEMCAD will use NRTL for some unit operations calculations, and it will use different thermodynamic model for these unit operations. Another way to see that is if I go to my reports and I would like to see thermodynamics, and this is my Excel report. It's gonna show me which unit operations have turned on the local thermodynamic model. Okay, let's move on now. So now that I have my FAME glycerol methanol in here, that will go to the FAME purification part of my process. I also have the catalyst that I need to remove, okay? So in order to remove my catalyst, it has to go through a different reactor in here. We're mixing phosphoric acid with it, so we get the trisodium sulfate and remove it that way. I'm adding 90 kilograms per hour of phosphoric acid in here. And I need to get the kinetics for my reactor as well. So we will go ahead and set up this reactor. So it's just one reaction, and it will be the liquid reaction mix phase. We're gonna run it isothermally again, and we're gonna specify the conversion. We're just gonna say that we have 100% conversion. So we click on OK. And now it's time to specify the base component. The limited reactant in this case is sodium hydroxide. And we're going to specify the reaction that is happening, that is sodium hydroxide. Here we go, with the phosphoric acid. And we will get trisodium phosphate plus water. And it's -3, which is for reactants, -1, and then 1 and 3. And we're going to have 100% conversion. And this is just a warning message because we don't have certain data for modified unipack, which is fine because we don't need it. So let's run this unit up. Unselected, it's okay. So we run it, and then we get none of the sodium hydroxide because everything reacted with the phosphoric acid, but we still have a lot of phosphoric acid in here that probably we don't need. And we get all the sodium reacting so that we form 13 kilograms per hour of the trisodium phosphate. So as I said, maybe we are adding too much of the phosphoric acid. So one way to optimize our processing here is limiting the amount of phosphoric acid that we are adding to our process. In some cases, depending on the amount of the catalyst that you add, you will also like to optimize how much of in this case the phosphoric acid you add to this process, so you don't have a waste. So in this case, I'm going to use this controller right here. This controller is a solver. It uses math behind it to try to come out with certain numbers depending on what you're looking for. In this case, I'm just gonna go ahead and tell the program that I would like, that I'm gonna set this variable right here, which is the total amount of phosphoric acid that enters into my reactor. And I'm going to make it equal to the sodium hydroxide because the sodium hydroxide is my limiting reactant. So I'm going to go ahead and click on OK. You can use this controller for many other things. You can also use it as a feed backward controller, so that you can change some variables depending on results in downstream of your process. So it's a very good tool to use in your process. I'm going to click on OK. And I'm going to run all now. It says that my flow sheet calculation has converged. The reason I ran all is because I already have these two columns set up, so I can run everything. If you don't have your unit operation set up correctly, you will probably get some warnings on errors because you cannot run all. So you can do what I was doing before, run selected, or run this unit operation is a good option if you have a flow sheet like this. Okay, so now let's see how much phosphoric acid I have remaining. So yeah, it went from, I believe it was kind of like 20-ish or 30 phosphoric acid kilometers per hour that were wasted because it was not reacting with the sodium hydroxide. So that now we have a very good conversion of the our reactants. All right, that was one way to optimize our process, making sure that you are not adding so much of the components that you don't need in your process. Using a calculator like the controller, it's a good way to do so. Another way to improve your process and make it more efficient is by doing optimization in the process, or maybe sometimes using a sensitivity study so you can see how some variables react to changes. In this case, I have a converge simulation. Let's see how much of the fame I'm getting right now. So we're getting 96%. In our case study, we said that we wanted to build a process that have 99% recovery of the fatty acid methyl ester. Let's look at the column and let's see how it is configured. So right now we have a partial condenser. We have a column with 8 stages, and our feed is at the 4th stage. We have a reboiler duty of 971 megajoules per hour. So our goal is to get 99% of the fatty acid methyl esters and to try to reduce the amount of our duty or our energy for the reboiler. How can we do that? There are several ways to do that. We're going to try to use the optimization tool because of time problems. I'm not gonna set it up, but I'm gonna walk you through how to set it up, okay? So usually when you have a new optimization case, you will click on here, create new optimization, and you have to give it a name, okay? I already gave a name to my case, so we're gonna go ahead and go to the edit. So as soon as you create your optimization case, you will be prompted to this dialog right here where you have to define your objective function. And in this case, I would like to, I put a title of column optimization because we want to optimize the way that this column is performing. We would like equipment 14, okay? Calculated boiler duty that we just saw that is 971. And the variable is in enthalpy units. And the object, you don't need to do this, but it is easier to see it in the report. So you put a name to your object, and we would like to minimize the calculated boiler duty, okay? Click on OK here. And then you need to specify your independent variables. So in order to minimize the boiler duty, I want the program to look at these variables right here and find the optimal number stages and the optimal feed stage so that my boiler duty is at minimum, okay? So again, we're gonna specify equipment 14 and number stages. As soon as you specify the ID number of your equipment, you will have several options, like different specifications that you have in that unit operation. In this case, we're choosing number stages. We're going to have a minimum and maximum. So the minimum number stages that I want is 6, and the maximum will be 12. I'm setting an initial value of 10. You don't need to specify, or we can specify 8 if we want. This is just an optional variable that you need to specify in here. Then we will specify the ID number 14, and we're going to do the same, but for the feed stage of my column. And it will be minimum will be 2, maximum will be 8, and the initial value will be 2. We click on OK. And we click on OK again, so we start calculating. And then we click on OK, and we click here, Run Optimization. So remember, when we look at the column, we have eight as the number stages, and we're feeding at stage 4, sorry. And we have a recovery of 96% of the fatty acid methyl esters. CHEMCAD will make several runs. It does 32 starts, so it will run 32 times to try to get the optimal. And CHEMCAD is telling me that the objective function value, which is the reboiler duty, will be equal to 927.5 megajoules per hour. Remember, the calculated boiler duty that we initially had was 972. So we're going to say, do you wish to accept the new process data? When I say yes, CHEMCAD will prompt the results, and it's telling me that the minimum is right here, this the optimum. And also it will tell me that it calculated a number of stages of 11 and the feed stage um, 2. Okay, so this is the initial value. This is what CHEMCAD calculated. Again, this is initial value and what CHEMCAD calculated. I'm gonna close in here. And because we said yes to the process data, um, CHEMCAD automatically will get it into the unit up. Okay, so 11 is the optimum, is fitting at stage 2, and it ran. So if we look at the convergence here, we can see that the reboiler duty is 927. And if we look at the recovery, is 99% of fatty acid methyl esters. So we got what we wanted from the program. So this brings us to the point where we can summarize the key takeaways from the presentation. So CHEMCAD enable users to create customized components in the case you need it by inputting data uh, from various sources for accurate simulation results, feedstocks properties like vapor pressure, heat capacity, evaporization, heat formation. You should be properly enter those into the system. According with the optimization result, a column between 10 to 11 stages with a feed introduced at stage number 2. It's necessary to achieve 99% purity of the paint recovery. And by utilizing recover controllers and optimization tools, you can improve product quality and optimize energy uses, promoting more sustainable biodiesel production process. We have tool templates and features available in CHEMCAD that aid in designing and optimizing biodiesel production processes. A collection of pre-built examples that are distributed with our program. They're available in the CHEMCAD NXT 1.1.3 examples folder. We have different data sets upon request for our customers that for different fatty acids that we can share. So if you happen to have a biodiesel process and you don't have data for your fatty acids, make sure that you contact support. Maybe we will have data for you. And you can also have access to research papers, technical documents, and other materials in our website. So what will be the next steps for you? You can review cases and technical papers in our website, as I said before. You can watch, record webinars. You might, if you are not a customer, you might request a live demonstration and also an evaluation of licenses. If you are a customer, please make sure that you contact support for any questions you have. And thank you for your time, and I'm open to any questions you may have. Noel, is there any question?
Hey, yeah, sorry. I was trying to answer some of the questions in the chat, so we do have some questions. Okay, so one of the questions was whether ChemCAD can estimate acid value and iodine value of fatty acid mixtures. My understanding is those are like lab measured values. I don't know if ChemCAD is predicting those.
The asset, you said asset values
Acid
and
value and iodine value of the fatty acid mixtures. So, um, I don't know, maybe something they can contact support about, but
yes,
my understanding is that's like lab measured.
yeah, we do have some correlations for some like of the critical properties, but we don't, I mean, we cannot predict properties unless we have data. As I said at the beginning, or at the beginning of the case study, if you have experimental data, you can regress some data in it so we can estimate, depending on your temperature and pressure ranges where you're at. But those correlations that we have are limited. So we uh, probably we don't have correlations for that type of data.
Hmm. The other thing is, so we have two questions on the specific property packages that you use. So, one is the liquid extraction column. I believe that property package was Unifac or modified Unifac, sorry. I don't know if
Yes.
you, okay, yeah. And
Yeah.
then the other one was which property package in the distillation columns?
Uh, for some of them, we use the general thermodynamic model, which is an RTL. And for the where there were liquid phases, we use modified unified. So we only use two different thermodynamic models.
Okay, I think you've already answered this one, but it says, what other properties can we get for any type of oil and catalyst? So you were
Uh,
talking about maybe support has some properties and then
Well,
also,
for the fatty acids,
Mhm.
we may have data for some of the fatty acids. And I said contact support. We have a list. I don't have all of those components on the top of my head, but we
Mhm.
have around maybe 7 to 8 different fatty acids that we have data that they are not included in the database because it does not come from deeper. Our database come from deeper, and it's public data. Those fatty acids come from different sources, so we have it on hand for our customers, but we don't have it in the component database.
Yeah, I'm thinking we're gonna do, we need to do another webinar on like what properties are in ChemCAD and what ChemCAD can help you estimate because there's, I think, a lot of interest in that, a lot of questions on, what exactly can ChemCAD help with as far as property prediction go and, what's in ChemCAD. Um, yeah, okay. So then um, it's again, what is the minimum information needed to define an organic component? So, I mean, again, we're talking about
Well, yes.
properties.
As I said, it depends of how you're going to use this component, right? The minimum that you need to create a component in ChemCAD is just the name and the normal boiling point. But in ChemCAD will try to give you some of the criticals for that and the eccentric factor, but that doesn't mean those are accurate. So it depends on what you need to model in the program, depending on the equipment that you're going to be using, you will require some certain type of data. So if you are just doing heat exchangers, for example, it is critical that you have heat capacity data, or heat evaporization data if you are vaporizing something. But I mean, to tell you what the minimum is, I mean, as usually, when we talk about process simulation software, depending on how accurate you want your results, we always say if you put trash in, trash out. Um, so you need to have enough information about your component and the data so you can have reliable results.
Um, so this is asking about the creation of solid catalysts. Can you create solid catalysts in ChemCAD?
You can create solids in ChemCAD. Yes, you can create it there, and you can use it in a way in those reactors. Um, yeah, the answer is yes.
Okay, is there any model regarding biodiesel production starting from solid feedstocks?
You mean, okay. So,
So
like,
like you'll have the corn mash or, whatever kind of solid that you start with.
mhm.
Um, but yeah, I think most from what we've seen of people using ChemCAD, they're starting after the solid.
Yes,
Yeah.
yes. What we have seen is usually you start with something that have been processed before. I did not mention this part, but we in the examples that we distribute with the program, we have also some pre-treatment uh, simulations before you get into the process that I showed you today. Usually people come from getting those processed before getting into our process simulation software. If you have solids, yeah, you're welcome to add it as a solid. Um, ChemCAD has mathematical models to deal with a solid, liquid, um, and vapor. Um, I will say, depending on your process, you may, if you have questions about it, we can guide you as the support team can guide you of what you need and how you need to process, or what equipment, unit operation you need to use in ChemCAD in order to get um, uh, your model um, correctly set up.
Okay. Um, so there's a couple questions, and I think it's relevant to bring up now that we do have a white paper, a technical white paper that kind of goes more in depth and kind of goes over this model. A consultant provided a lot of information for us. So we can send this out to people if you contact the ChemCAD support team. We can provide a more in-depth technical white paper. We will also be sending this webinar out, the recording for this webinar out in an email following this. So if that's useful, and then I mean, I don't know that we'll have a chance to get to all the questions because they're continuing to roll in. So we will be contacting you guys that are sending these technical questions in the chat. But I don't know. I thought it would be interesting to hear from you. We have a few people asking about ChemCAD in the sales aspect of how do we get access to ChemCAD? Is there an evaluation license? And also we have someone asking, what is ChemCAD versus Aspen Plus? They're two different simulators, but they're both process simulators and they're just provided by two different, software. So if you want to talk a little bit about ChemCAD and how they can get an evaluation license if, people are not already ChemCAD users. If you're already a ChemCAD user, and you have technical questions, please contact support. And we do see your questions here in the chat. We won't have enough time to get to everybody today, but we will be contacting you to get in touch with you about those technical questions. But maybe just spend the last 5 minutes that we have, Alejandra, talking about how people can get in touch with, I guess you or a sales representative to get an evaluation license.
Sure. Yeah, well, if you saw my presentation, yeah, ChemCAD is a process simulation software that will help you to get your process um, model and get results before you even try to get your equipment set up. The difference between us and the competitors, we have pretty much all the mathematical models that our competitors have. Um, what differentiates us from other softwares is our willing to work with you as a partner. We have an incredible support team where and we are all chemical engineers here to support you since the beginning of the process. Um, if you're not a customer, you can send an email to sales@chemstations.com. And we will contact you and send you some information about how you can request an evaluation. You can also go to our website and request a trial evaluation. So you will be assigned with somebody in our sales team, and I'm usually on those calls to try to understand your needs of the program and to guide you on probably getting a free evaluation of the software and also getting another type of demonstrations for your specific needs.
Yeah. Thanks, Alejandra. And I'll also just mention, we're having this industry-specific topic in biodiesel because we've, had a lot of interest in it and, current customers using CHEMCAD to do biogas, biodiesel type of work. We also have a professor in Germany who I know is working in biogas. So it's just been like information that we've heard from customers and collected. And like I said, we have this kind of technical white paper. So we just thought, we had some information that we could share with you, but we don't want to say that that our support team or that our technical team here at ChemStations is a are experts in biodiesel or biogas, but we'll help you as much as we can with the information that we have and what we've collected. And, we'll get from you, your questions will let us know more about the product because, you're asking about what's interesting to you and that's how we learn also, what our customers are doing, what they're using, how they're using the product. And so we're just trying to pass on as much information that we're learning, and we'll try our best to support you in using the product for, your biogas, biodiesel processes. So, okay. Anyway, I just wanted to mention that you did great, Alejandra. Thank you so much for this informative webinar. And like I said, we aren't going to have enough time to get through all these technical questions, but yeah, we will be contacting everyone if we have your contact information um, from your Zoom chat, and we'll try to get with you and support you in your technical questions. But with
Thank
that, yeah. Thank you, Alejandra, and thank you everyone for attending this webinar, and I hope you have a great day.
you. Bye.